we got to see that whenever we have a changing magnetic field, we have current induced. Now the question of how much current is what we're looking at. How much voltage is what we are trying to answer. We got to see the directional aspect. It has to be such that it will oppose the change, and it has to conserve the energy. Law of conservation of energy has to hold good over there. Now, how much energy is transferred and how much voltage is stored and so on and so forth, that's what we are trying to understand. So this is done under the heading of motional EMF from Faraday's law. First thing is EMF stands for electromotive force. It's another way of talking about voltage. So here, why does the word motion comes into picture? We are moving something. For example, we have seen this before. I don't know if you guys remember. This has to do with motor, right? So motor and generator are interchangeable. So here we're looking at a DC motor per se. So what is that I'm doing is I'm rotating the setup, the coil clockwise, and we see a negative voltage over here. Now we're rotating it anti-clockwise and we see a positive voltage. Clockwise negative. Anti-clockwise positive. So directional aspect makes sense. It has to do something. It has to be something that will oppose the cause. And we looked at the amount also, right? We looked at varying voltage, varying your EMF. That is your EMF basically. What we just saw is your EMF. Because of a motion and induced, we are inducing an EMF, a voltage, right? We are able to produce an EMF by moving a conductor. And what we just saw was a motional EMF, example of motional EMF. And if we connect this to a bulb to the end of a conductor, we get light, obviously, right? We have a source of electrons moving, make this electron move through a bulb, the bulb glows, as simple as that. Now, as a definition, the EMF induced across the ends of a conductor due to its motion in a magnetic field. Just by moving a wire somewhere in the air, it won't work. It has to be in presence of a strong magnetic field. This essentially, it's essentially the voltage that arises due to the motion of a conductor in the magnetic environment. I think I have one more thing. Why this happens? Again, this is for your curiosity. This is not for exam point of view. Imagine a wire moving through a magnetic field. A magnetic field is like a force field that can push and pull on things. In this case, charges, right? We have seen that. It can change the direction of the charge, moving charge. So since wire is moving, charge will also move, and so on and so forth. We have seen this in detail in the last chapter. When the wire moves through this force field, the electrons moves within the wire, which is also free to move, and which also feels the force. This force on the electron causes them to move within the wire. As they move, they create an electric current. As simple as that. Again, these are all introduction. I'm just introducing the word motional EMF. We'll be understanding a lot more in the coming set of videos.